Welcome students, and what we're getting into are how to convert polar coordinates and into rectangular coordinates and then vice versa going backwards. Just understanding this graph here or this example will give you all the details. I mean, you could plot it by using the red and go from X to Y, just like we normally have been since probably middle school for most of you. Or you could do the blue, which you do the rotation and then whatever this radius is. So really, it's getting to the same location, but using different directions here. This one just goes right, then up. This one just rotates, and then whatever the radius is. So first of all, let me go ahead and write out some notes like how to convert back and forth. So if we're trying to convert rectangular to polar, basically the rule goes, and basically what I'm trying to say there is like rectangular, you're given the X and Y value and you're trying to find the R and the theta value. So you're going from XY to R theta. So the formula goes X squared plus Y squared equals R squared. Just like Pythagorean theorem, not surprising because if you look at the picture, and then the way that we find theta, since X and Y is given, that's the opposite over the adjacent, which would give us the rotation. Again, the unit circle would be very helpful at this moment. Now, what if we're given polar and we're trying to return this into rectangular? Polar again is R theta, rectangular is XY. So now we're going from the rotational aspect to just the rectangular, which is moving left and right, up and down. That's even easier. Just have a calculator handy because it's just R cosine of theta, R sine of theta. And then that's it. That's all you need to know, like how to convert these. So going back and forth, that's really your rules here. All right, so as the first example here, they give you the polar coordinates, which is given. Find the rectangular. That's all you're doing. So let me go ahead and let me change colors again. This is R 270, and then you're trying to convert it into XY. So what we're trying to convert this into is the X and Y coordinate. And like I said, a unit circle might be handy, so I went ahead and got my unit circle. First of all, whenever you're converting from polar to X and Y, it's almost wise to start off with what's the rotation. And as you can see down here, this is the rotation. Now, I'm trying to get into the X and Y value of it. So it really has a radius of 8. My unit circle already has a radius of 1, and that's what we always assume the unit circle to be, radius of 1. We just have to extend this down 8 times. So if you look at the way this is going, and again, I can go back and use my formulas here. X equals 8 times cosine of 270. Y equals 8 sine of 270. And again, what's going to happen when you type this in the calculator, you're going to probably get, well, you're going to get exact answers, but sometimes you're going to get decimal answers. Just get the answers off the unit circle. Since this is the location, 0, -1, just times it by 8. And when you take 0 times 8, you get 0. When you take -1 times 8, you get -8. And that is your solution. 0, -8. Check your solution, and it's perfect. All right. Let's move into a harder problem here. Let's actually take a look at this one, and then I'll even do a rectangular to polar just to make sure everybody's okay with the direction here. All right, so this one's it's giving you a radius of 5, and it rotates 5 pi over 6, and we're trying to convert this into XY coordinates. We're trying to convert into that. And again, you can go straight to the formulas and do the X equals 5 times cosine of 5 pi over 6. Y times 5, I'm sorry, let me say again. Y equals 5 times sine of 5 pi over 6. And again, if you type this into the calculator, you're going to get some crazy answer. But if you look at 5 pi over 6, right here is 5 pi over 6. I'm going to use that coordinate, negative square root of 3 over 2, and then 1/2. So let me go back. I'm actually going to change it into a color. So this, for the unit circle, is actually at negative square root of 3 over 2, and then positive 1/2. Wow. Hope you can read all my handwriting there. Positive 1/2. And all you're going to do is just take the 5 and multiply it by both of them. So it's going to become negative 5 square root of 3 over 2, and then 5 over 2. Now, you could, again, type this into the calculator. It's going to give you horrible answers, but I can imagine here it's going to say use integers or fractions, simplify your answer, include any radicals. So they do want the exact answer. So let me go ahead and type this in. Negative 5 square root 3 over, oh no, I got to put that on top, that 5. Negative 5 there. It might just take more time typing it in. Actually, you guys are probably faster at this. And then check my answer, and then there's my solution. Let's do a problem where we're trying to convert rectangular into a polar, just so you can see the characteristics, what's going on. Let me scoot this up again. I'm going to finish it up with the green color here. So they're giving me negative 9, 9. That's the x and y value. And what I'm trying to find is the polar. I'm trying to find r and theta. So basically what I need to figure out, and again, if you forgot the formulas, it's just x squared plus y squared equals r squared, and then tangent of theta equals y over x. Well, we'll do the Pythagorean theorem first. So negative 9 squared plus 9 squared equals r squared. So really at this time, you're just doing Pythagorean theorem. It's going to become 81 plus 81. The bad thing about this is you're probably going to have to simplify the radicals. So don't be surprised. Simplify your answer as it says there. Just like here. If I take the square root of 162, and I have to break it down. 162 is obviously 2 times 81. If you think of square roots on both of those, then basically it ends up to 9 square roots of 2. That will be my r value. Now, let's talk about the theta. This is a little bit trickier. You're using your unit circle. So what you should know, first of all, I'm going to use a different color here. I can just actually say theta equals the arc tangent of y over x. I'm sorry, I forgot what was y and I forgot what was x. 9 over negative 9. So 9 over negative 9. Now, basically I'm looking for when is tangent equal to negative 1. All right, so if I go back up to my unit circle, the problem, whoa, I didn't mean to move that. The problem with that is there's 2 locations where tangent equals negative 1, has a negative slope. It's at 3 pi over 4 and 7 pi over 4. Now, which answer do I go with? Because there's only one solution. You can't have 2 different rotations there. So is it the 3 pi over 4 up here in the second quadrant or 7 pi over 4 down here in the fourth quadrant? Well, kind of cheat and go back and look at the point that they gave you. They gave us negative 9, 9. That means we have to do negative first and positive second. Well, which one will go negative? That will go left. Which one goes up? That will go this one. So it has to be the 3 pi over 4. So you do have to kind of cheat, go back, look at the point. So my final answer on this would be 9 square root of 2, and then the rotation would be 3 pi over 4. Unless they want the, and they do want the answers in radians, so do pay attention to that. Take your time, make sure you do your work. If you have any questions or concerns, I'm always available. Thank you. Have a good day.